Hello. Oh, I'm amplified. Hello, everybody. Thank you for joining us for this session at Siggraph today. I'm so excited to be here. Is this volume okay? Everyone can hear me? Fabulous. This light is so bright, I'm going to have like a tan by the end of... So yeah, thank you so much for joining us today. My name is Liz Mercuri. I'm part of the Evangelist team for Europe. So this is my first time in Siggraph and my first time in Vancouver, so I'm really pleased to be here. So thank you so much for joining me on this session. So what we're going to talk about today is actually the fact that you can use Unity to build awesome applications regardless of what industry you work in. And what I'm going to cover today is actually an introduction to lighting in Unity. But before I get started, the fundamental question, so we're all on the same page. What is Unity? So who here uses Unity day to day? That's good, yes. So for those of you who didn't raise your hand, who here has heard of or played Pokemon Go? Some of you are lying, come on. So I love using Pokemon Go as an example because so Pokemon Go was made by Niantic using Unity. And the great thing about Pokemon Go is it appeals some amazing statistics for me to use. So the first is that over 50% of the new mobile games that you will see on the marketplace and the top 1,000 mobile games are made with, and 50% of the top mobile games are made with Unity. Furthermore, if you've ever tried augmented reality, like Pokemon Go, or virtual reality, over 60% of those applications are made with Unity. So Pokemon Go is just an amazing little flagship of what Unity has to offer as an engine. But it's not just games, and it's not just mobile. So who here has seen the new Blade Runner or Jungle Book? Raise of hands, raise of hands. Brilliant. So Unity was actually used in the virtual production of those films. And Unity, as you may have seen if you visited our booth in the exhibition hall, it's actually been used to make not only in the virtual production of full sort of films, but it's actually used in animated films too. And going on a little bit further from that, Unity is also used in automotive. So if you pop along again to the Unity booth, we have a really cool Lexus demo. And actually, all of that model data has been imported into Unity, all of the CAD data with something called Pixies. So again, Unity is being used for visual production and also sort of automation of CAD data too. And that's not all. Like I've mentioned very briefly about how we're used in architecture, but also used in research. NASA Jet Propulsion uses for their research, which is super exciting. Simulation and education, which is why I'm here. So if I pop over to the big summary of what Unity is, I've just given you all that big sort of blast of information. But in a nutshell, we're a real-time content creation tool. And I'm going to share with you more about that concept of real-time when we get into the lighting in the engine shortly. And one of the other things about Unity, I've said virtual reality, mobile, console. Actually, there's over 25 platforms that you can deploy to when using Unity. So not only is it used cross-industry, it's also cross-platform too. So everything that I'm going to talk about today in terms of lighting is going to be applicable to you, regardless of what industry or platform you're deploying to. And if you want to chat to me about any specifics after, chat to me here, or I'll be at the booth. So the talk agenda, what are we going to cover today? So what I'm going to go over today is, so I saw that the majority of this room don't use Unity day to day. So there's going to be something in this talk for people who've never used Unity, but hopefully some nice little hints and tips for people who have to take away. So the whole idea of today is that we can use Unity not just for games, although games are awesome, but actually in non-games like in architecture or visualization. And what I'm going to do is take you through a project which is a kitchen configurator. So much like, I don't know if you've seen, there was an augmented reality app made with Unity by IKEA. This isn't it, but like a similar concept that You can choose furniture for your room and then swap and change it in real time to see how it matches the environment. So I'm using a project, which I'll show you in a second. And what we're going to do is build up that scene together to create realistic lighting. So we're going to start with the default setup of Unity, what you get out of the box. We're going to see how we can leverage that. Then we're going to look at some realistic lighting techniques that are super quick and super simple that can very quickly get you more realistic lighting. Along with lighting, we're going to look at reflections. And then finally, we're going to look at our post-processing stack that you can get in Unity, just to bring together the cohesion of your scene graphically, and also really help the lighting pop. So that's what we're going to be going over today. So as I said earlier about me being here because of education, so everything that you see today is actually one of our workshops, which is an introduction to interactive 3D. So this project is actually out there being used, and we're going to go through it, which is super useful. So enough of me waffling on. Is that a British term? Waffling? Waffling? I don't know. Let's jump into the editor, and I'll show you what I mean. So here we have our final scene that we're going to work towards. So if I go into play mode, we can see here that I have this scene that's lit. We have ambient lighting in there. We have the use of spotlights. These lights are real time, and I'll show you what I mean by that in a second. We have the post-processing enabled. And we also have real-time reflections set up too. So as I said, this is a kitchen configurator. So what that means is I can take a look at, let's say this is my kitchen, beautiful kitchen. I can focus in on that cupboard there, and I can actually take a look at the options that are available to me. So if I want to update the type of granite that's used on that worktop, or the wood, for example, or you can see the type of material used on those drawer pulls. If this is being used in production, if this is being used in a virtual showroom, we want the reflections and the lighting of this to update in real time to reflect how that environment would look with these materials and textures on there. So this is what I'm going to show you. This is the project that I'm going to use to show you how to achieve this today. So let's go to a starting scene. So we can see straight away when I go into the starting scene that it's a little bit more drab. It looks a bit sad than the one we had earlier. But this is a great way to show you what you start with Unity as a base. So when you open Unity, the two pieces of lighting components available to you is this directional light here, and something called a skybox, which encompasses this whole scene here. You can see like this horizon in the background. So what a skybox is a cube map. It's a collection of 6 textures which encompass an object. So it's like you're getting information from all of those axes, up, down, left, right, backwards, and forwards. So the sky that we see projected here is a cube map with our kitchen in the middle. And this is what you'll get as default when you open Unity. And these two work together because the directional light works as the sunlight, whereas your skybox is your ambient light. So if I was to rotate the directional light in this scene, you can see that that actually affects where the sun is in the sky on the skybox. So as the sun goes down, the environment gets darker. So they go hand in hand. There's actually quite a few settings that you can do just to tweak the default settings out of the box. So if we go to Windows and Rendering, there's actually light settings, which I'm just going to dock here. So we can see here that the skybox material is set up to just be a cube map, which is this sky, and the sun source is this directional light. There's also settings here for the environment reflections. So at the moment, all the reflections that we see in the scene are just that of the skybox. So if I go over to this refrigerator, for example, we won't see anything in the scene reflected at the moment, but what we'll get is this kind of gradient color of the skybox, and they're the only reflections that we have at the moment. So this is the default setup. Like I said, we can tweak it here, but there's a lot more that we can do to be able to get this environment very quickly looking more realistic. So I just want to talk, I want to start like right from the very bottom, and I just want to talk about how Unity handles lighting first and foremost. So if I remove this directional light, you'll see a change, but you'll see that actually the environment is still lit. And this is because Unity actually works with global illumination. So in the Lighting Explorer, you can see here that we have real-time global illumination and also baked illumination enabled. So all the direct lighting is calculated by Unity. All of the indirect lighting is handled by a middleware called Enlighten. And what I mean by direct and indirect lighting is, at the moment, if we look in the scene, we can see the light coming through the window directly hitting surfaces. But actually, we have illumination in other areas of the scene. We have this bouncing of light and this softer lighting in other areas. And actually, if I change the skybox color, this might make a bit more sense. So as I make the scene more red, we can see that the direct, like this window frame, for example, where the light directly hits, we get this red hue, whereas further away, we just kind of get an essence of that. And that's global illumination coming into play. And the use of sort of direct lighting and global illumination is what Unity really leverages to bring realistic lighting into the engine. Again, back in the lighting, if I switch the directional light back on, we can actually see that this indirect multiplier is actually how much of the lighting bounces we want. So cranking this up will actually make the environment brighter because there's more indirect light being bounced in the surfaces. So that's just a little bit of background knowledge. You know, it never hurts. So that's Unity, what you get out the box. So your directional light, your basic skybox. So what fast, quick, easy things can we do to easily make it super more realistic? I'm going to go over two things. I'm going to go over a different type of skybox, and I'm going to go over the different lighting types in Unity. So who here is a photographer? Cool. And so who here has heard of HDRI? Fab. OK, cool. So what I'm going to introduce into this scene is actually a HDR skybox. And what a HDR image does is it's actually a concept used in photography to capture greater amounts of luminosity, so a larger range of lighting information in your images. And digital content creation tools like Unity actually have the super powerful ability to take that lighting information from an image and translate that into virtual light. So the more lighting information you have in your image, the more Unity has to deal with to be able to translate that into more realistic lighting. So you can actually get this pack from the asset store for free if you want to play with this. So it's the Unity HDR pack. And once they're downloaded in your scene, you can navigate to the folder. I quite like the Kirby Cove ones. And back in our lighting inspector, all we have to do is drag and drop that new skybox into the inspector, and we'll see the effect straight away. So this skybox is a cube map of Kirby Cove with all the ambient lighting information and the sun in the sky. So we'll see that we now get that lighting information translated into our scene. It's a lot softer. We get that sort of green effect and the warmth of the sun. All of that translates into our scene, which is just so much richer than what we had with just a default skybox with a gradient image. You can kind of, again, have control over the skybox itself. So you can add, if you have a cube map image that you want to use yourself, you can add that. And then you can add small tweaks like the rotation of the image if you're wanting to adjust the lighting, sort of that ambient lighting. But the use of HDR is super useful when working with getting realistic lighting in Unity. So I spoke about a light type which was directional. And this is effectively the sun in our scene. And there are multiple light types in Unity. I'm not going to go over all of them today, just a few. But each of the light types in Unity have a set of values which can be tweaked to get the feel that you're looking for in your project. And these are things that are sort of as small as the color, if you're wanting to change the overall color of your scene. And then more apparent things such as the intensity, which we can crank up, and it's super crazy. And then that indirect lighting that I spoke about. Each of the lights in Unity will also give you options for your shadows. So this comes into play depending on the type of project, sort of application that you're looking for. So if you're deploying to mobile, for example, you might want to use quite low resolution shadows for your lighting. You can see this update in the editor straight away. Or stick to the high resolution, sharp ones if you're sort of targeting more high-end devices. You can change the bias of these too, so how far from the light source the shadow will begin. There is so much to go into in terms of in the graphics settings of Unity in terms of shadow and shadow distance when you come to sort of optimizing your projects. So shadows is just something to bear in mind when you're sort of getting towards finalizing your scene in terms of lighting. If I scooch along to spotlights now, I'm sure you've all heard of spotlights in some way or another. So it looks like a lot of splashy lines at the moment. But these are, as you would imagine, when you sort of think of a spotlight on a stage with a singer, that's exactly what it is, minus the singer. But again, we can sort of tweak the settings here. So the range, like the attenuation of the light. We can change the spotlight angle. And we can change the color. Now, you may have seen that I've been skirting over the fact that there is another option with all the lights, which is this idea of real-time mixed or baked lighting. And this talk is about real-time applications, so it would be really bad of me to not talk about this in more detail. So let's just take a look at a different type of light before I go into what the differences are in the use cases. So if I select all of these spotlights here, and I'm going to set their color to red, and I'm going to give them a wide range. I'm a great artist. Update all these. You can see that as I'm making these changes, it's happening straight away. You're getting that direct visual feedback in the editor. And this is because when we use real-time lights, real-time shadows in Unity, everything is calculated per frame. So all of that direct lighting is being calculated per frame. All of the indirect lighting, which is being calculated through Enlighten, the middleware, is actually creating light maps of that indirect data, which it's accessing. So the use of real-time lights is super expensive. And if you have complex scenes that you're feeling that you want to use real-time lights, like for example, in this, we want real-time lights, shadows, and reflections, because when we update these surfaces, we want it to reflect the lighting that is being received by that surface. So what we usually recommend is that you lower the resolution of your light maps if you're using real-time lighting for the indirect lighting. And this is in your lighting option. You can see here under your light map settings, you can change the resolution of your light map size. And sorry, I've skipped ahead there. If you've not used lighting before, a light map is effectively a texture of all the lighting information that has been pre-calculated before runtime, effectively. So all of the indirect light is stored in those light maps. So we can see that all this updates in real time, and that's great. But Unity also has a different type of light, like, for example, these area lights. They're actually, as you can see here, say baked only. So we can see here that we're expecting a light of this green color. And the area lights are like a flat surface that emits light that I've just placed here in the windows. So you can sort of see them here. Oops. Eek. Oh, no. Let me select you both. There we go. These two here. So to use baked lights in Unity, what you actually have to do is pop to the lighting tab and generate the lighting yourself before you see any of this happen, any of the effects, the changes, the effects take place. And this is because for baked lighting, all of the lighting information that is needed for the scene is baked into these light maps. So nothing happens at runtime for baked lights. And there are some kind of limitations in that, for example, no lighting information is accessed at runtime. So for example, like the direction of the light can't be accessed. So sort of specular, the idea of like specular surfaces can't be interpreted at runtime if you're using baked lights and that kind of thing. But if you know that you're going to have objects in your scene which aren't going to change, you can actually mark them as, and a few of these kitchen objects are, you can actually mark them as light map static. And what that is saying is it's indicating to Unity that this object isn't going to change. You can bake it into those light maps, and it's not going to update, like it's safe. I'm not going to crazy go into it a lot today, but it's just useful to know that there is a compromise between the two of real-time and baked, and that is mixed. And mixed lighting gives you the functionality of real-time lights, but in really kind of strict constraints. So again, it's dependent on your project and what you're wanting to show, and also the device that you're targeting. So if you're looking at mobile, for example, it might be a good idea to reduce the amount of lights in your scene, stick to baked lighting. And I've seen a lot of people who will fake shadows. So they'll attach like a sort of shadow image under an object or a character to move with it. There's some great Unity manuals and blogs that have some great sort of optimizing techniques and tricks. Whereas if you do have a high-end console that you're targeting, use of real-time or mixed could be really useful for you if you're wanting to maintain that real-time lighting and reflections. So now we can see that the effect of the area light is, let me get them both. One is pink. That is why I set them to different colors. That helps nobody. So with the use of Enlighten, as you've seen previously, we have to wait for this bake to happen. If you do have a large scene and you are wanting to bake a lot of your lighting, you can actually switch to, and again, I'm not going to go into this super crazy now, but you can actually switch your light map settings to progressive. We have a demo of this on the Unity booth. And what this does is it allows you to focus whatever is in your scene view. So if you've got an area of your scene that you really want to focus on, you can move your camera to there, have that set up in your scene view, and it will just bake that area of priority. So it means that you can really focus in on the area you want and iterate on that a lot quicker. So that's through the use of progressive. Because you can see this is quite a simple scene, and if you're wanting a really quick workflow, it might take a while. That looks like Resident Evil or something. And again, if I remove those lights, I'm going to have to generate the lighting again to remove the effect of them. So that's just an overview of the use of a HDR Skybox and actually the different lighting types that you can use in Unity to get more realistic lighting and shadows and sort of the options that are available to you. And it really is dependent on sort of your use case and your project. I've only given a few sort of hints and tips, but there's a lot in our documentation. So then I think the next bit which would be useful to add is earlier on I mentioned about the reflections on this refrigerator. And you can see, again on this kitchen top as well. This is because I put my spotlights to red. That we're getting reflections from the skybox and the other lights in the scene, but we're not getting reflections from other objects in the scene. And the way that Unity achieves this is through the use of something called a reflection probe, which I have here. I'll just unhide it. So all of these lighting types that I've spoken about and also reflection probes can actually be accessed through the Create menu under Light. So you can get them there. They're all contained. So the reflection probe is, much like the Skybox, another cube map. And what that does is it takes a snapshot of the scene and projects it into a cube map that is used for the reflections. And this scene is quite small, so I only have one. But if you have a complex scene of corridors, you can have multiple light probes in one scene. It's worth bearing in mind that any objects will take the nearest reflection probe for what it's going to reflect onto it. So you could have, so for example, if you wanted different areas of the kitchen to reflect different things, it'd probably be a better idea to have one reflection probe one side, one the other, just to get like a more varied collection of the reflections available. But if you do have a simple scene like this and you just want to use the one, there's a number of options that you can use to customize it. So you can actually change the bounds of your reflection probe. So this bounding box that we see in these pulleys here, they actually let us define how far we want the capture of the environment to be. What are the bounds of what we want to put on this cube map for the reflections. So at the moment, I've just got the room kind of in these bounds because that's all I want to take. And then similarly, if I then sort of moved this, it would move the bounds with it. And sometimes you might not want that. So you can actually just isolate the center with this probe origin here. And then you can move the reflection probe around as just. At the moment, this reflection probe is actually set up to be real-time, which, again, like the lighting, has constraints with it because this cube map will update every frame. You can also use a custom cube map. So if you've collected your own reflections, you can add the cube map there. And then there's also the option for baked as well. Again, if you have static geometry where the reflections aren't going to change. Back to real time, though. I think it's just worth mentioning as well that actually the reflections can be updated via script. as well. So the refresh mode doesn't have to be every frame. You can actually take these reflections and update them every 5 frames if that's what worked for you in your project. And as I said, the reflection probe is just using a cube map, so you can actually choose the resolution of those reflections too. So again, dependent on device. So now, with the use of my lovely reflection probe, you can see now, the reflection probe will move out of the way. You can see now that actually this kitchen counter is being reflected in the refrigerator. So we're actually getting those reflections from the environment captured in our scene. Sometimes this can lead to self-reflection though, which isn't useful. We don't want like the windows, for example, to reflect themselves. That would be weird. And sometimes, just depending on your project, you might not want something to be in the reflection probe. So what the reflection probe has is this concept of a culling mask. So at the moment, we have a layer that we've set up in Unity, which you can do from this layers menu here, called Do Not Reflect. So if I take this cooktop island, and we're just going to put it on this Do Not Reflect layer. Yep, I want that to change everything. Then I'm going to pop back to the reflection probe, and I'm going to say, so that's now getting everything. I want it to include everything apart from this do not reflect layer. So we can see now that that's very small, isn't it? Sorry. We can see now that this reflection probe doesn't include the countertop. And so that means, as a knock-on effect, that it's not going to appear in our reflections. So yeah, the removal of a kitchen counter isn't the best example, sorry. But I'm just trying to say that you can occlude areas of your scene that you don't want to be included in those reflections too. So that can help with your realism in some instances as well. A way small preview window. So that is sort of a very brief introduction to reflections with your lighting in Unity with the use of reflection probes. The final thing that I just want to talk about is post-processing, because post-processing can really help to just bring your scene together. And there are a few options in the post-processing stack that can really help to pop your lighting and just sort of enhance that realism. So has anybody here used our post-processing stack? Cool, a few of you, that's great. So I'm just going to give an overview of how it works. So where's my camera? There's my camera. Oh. So on my camera, I've got a component which is this post-processing layer. And the post-processing layer, whatever is added, whatever component has this layer is what's going to show the effect of this post-processing, if you will. Then we also have a trigger as well, because this scene is very small, and so we're only using one post-processing volume, but you can actually have multiple. And when I say a post-processing volume, it's actually a box collider with a trigger. You can use a mesh collider, and you can just define the areas of the scene that you're wanting these post-process effects to be in. But as I said, this has just got one post-process volume in there. But this trigger would be what would move between those volumes and trigger that change on the main camera. Anti-aliasing is on this main camera. It's no longer part of the post-processing stack. It's actually all here. So we've got, again, depending on sort of what device you're targeting, we've got some the FXAA all the way through to your temporal anti-aliasing if you sort of have some movement in your scene. And also the fog can be enabled from here as well. So this post-processing layer on the camera just says, hey, that you're going to view all this post-processing and handle all that. And the camera goes, OK, but where are my volumes? So if I just enable these volumes, you can see the scene like changes straight away. So this post-process volume, at the moment I have this selected as global. So that means that if the post-processing profile is global, it affects the whole scene. There's not individual volumes that can override the global profile. Just the whole profile, the whole scene is going to use this single profile. And you can create an entirely new post-processing profile, which looks like this. It's just totally blank, and you can build your effects up. But we have one already made, which is this kitchen profile, just so I can show you the bits and pieces. So I'm just going to switch all those off, and I'm just going to go through the ones that I think are super useful for lighting. So the first one that I think is grand for lighting is the use of ambient occlusion. So ambient occlusion is a means of areas of your environment that would be naturally hidden from, so naturally occluded from direct light, will have areas of darkness. So for example, the corner of this room, the light is occluded by the refrigerator. We expect that the corner of this room is going to be dark. And the use of ambient occlusion just helps to exaggerate that. And it's super useful for creating more realistic lighting. Just a note, some of the effects of the post-processing stack are very intensive and not recommended for mobile. But some of them, such as bloom, which everybody loves, you'll see that they have something called fast mode. And with this enabled, it actually optimizes the effect for use on mobile and virtual reality. Not all of them have this, but it's just worth bearing in mind depending on your platform. So the bloom kind of pulls out the light in quite a bit. Can we see if yeah, can see how that pumps up the light in the scene. That's not particularly useful for lighting, but everybody likes a bit of bloom. The use of screen space reflections is also quite useful for lighting, because what these do is they take the reflection information that we already have in the scene and then use this to make more subtle reflections. So again, it just helps to pull together the realism of the scene that you have. A vignette, that was just for my own self-indulgence. Why not? And then finally, one that I just think is really useful for just bringing the cohesion of the scene together and giving it like an overall kind of feel is the use of color grading. That looks crazy at the moment. Is it those spotlights? Yeah. Let's just make them a little bit more normal. Oops. Boop, boop. Did I get that one? No, OK. There we go. That looks better. So, color grading. So again, we have, so color grading is going to help you to balance the colors that you have in your scene. And again, we have modes dependent on what platform you're targeting. So we have the HD range for higher end sort of PC and console. And then we have the low range for mobile devices. One that can get you started straight away is the tone mapping. So at the moment, we have it set to neutral, but ACES will drastically change it. You can change the temperature of your scene. So if you're wanting it cooler or more warm, like warmer. There's tints as well, so you can add a color tint. A color filter. And I know that some people add a color filter and then they turn the saturation all the way down to get like a black and white image. That's quite helpful. Not for realistic lighting, but you know, just in case you were making a black and white application. And then I think the thing that's cool, just like the icing on the cake for that fine tuning, is we actually have the ability to sort of pull the colors per channel. So the channel mixer here can be controlled by the trackballs, and each of the trackballs represent the low, middle, and high tones of that channel. So if you, like a few people in my team, have an eye for fine-tuning details, you can actually use these trackballs to affect the low, medium, and high tones of your scene too. Oh. So with the use of post-processing, you can just really bring the cohesion of the scene together and just add a little bit more to it, which I just think is really useful. I think it looks so much nicer and so much cleaner. So that's kind of my like boot camp, quick intro into lighting in Unity. So just as a summary then, default in Unity, you're going to get your skybox and your directional light, so your sun and sky, effectively, that you can change from the lighting settings. And also, we have this idea of direct and indirect lighting. The indirect lighting, global illumination, being handled in our light settings by Enlighten. Then we had this idea of what could we add to the scene that's super quick that we can tweak to just add realism straight away. And that was the introduction of the HDR Skyboxes, which you can get on the Asset Store for free, and different lighting types, and also the use of reflection probes for more realistic reflections. Then we looked at real-time versus bake lighting, depending on your project and what hardware you're targeting. Then finally, just to pull all that together, we had a little look at post-processing, which is available on the package manager from, let me show you that actually. I didn't do that. So we have this package manager. This UI was actually new in Unity 2018 too. And what this is it's all Unity-made packages, so like post-processing, that you can like add and remove to your scene. So add and remove to your project. So actually, you only have in your project what you need, and it's so much more modularized and easy to handle. So post-processing is part of this, and as updates come out, you can update them straight away. I should have mentioned that. My apologies. Oh, no. There we go. So yeah, post-processing is via the package manager. I mentioned these at the beginning, but actually we have some awesome blogs on lighting in general, post-processing. This blog in particular I think is awesome. It's our Spotlight team, and this isn't just lighting. This covers the whole pipeline of just getting really high quality visuals in Unity. It's a really great blog post. Secondly, I've popped a link to our Unity YouTube channel, because we have our talks from our Unite conferences on there, and there's always like the newest innovations, there's talks about it, it's out there. This particular link is from Unite Berlin, which was in June, and it's talking about all the new bits and pieces that have come with post-processing. And then finally, I mentioned that this is actually a subset of a whole day workshop that is available. And the Unity training workshops are for teams, so studios of around 15 people that actually just want to learn an aspect of Unity in a day. And it's instructor-led, so someone from the Unity training team will come to you and deliver your training to you. This is a subset of one of them, but we do have quite a few now. And we also do custom ones too. But if you are an individual learner and you've been on our Learn channel, our blogs, our YouTube videos, and you want a little bit more, we have virtual training too. So you can sign up online and just be part of like a 4-week course, rolling course. I think the one that at the moment that's going on is optimization techniques, which is pretty cool. The guy that I sit in front of in my office actually runs them. True story, from the UK. There we go. So yeah, and as I said, I'm going to be on the booth. The education team are at the booth. We've got progressive light mapper. We've got Siggraph. We've got post-processing. We've got all sorts. So we're booth 817, Matt. Is that right? He came to listen to my talk. Are we 817? Right now? Our booth. Yeah, I was right. I was right. So please do come and chat to us. And thank you for your time today. I really appreciate it. So thank you very much.